All right, let's take a problem end to end and find the area of a shaded region given its description. We've got y equals x squared, y equals 12 minus x. Let's just find the total area for that red shaded piece. Okay, so the first things we need to do is we say, okay, I've got these red pieces. Let's find the boundaries. Let's find those intersection points. We need to find this point and that point. So the way we're going to do that is we're going to say, okay, well, at these points, the graphs cross, so the function values have to be equal to each other. I'd say, okay, well then, x squared has to equal 12 minus x. That's just part of the problem. So then if I rewrite this all on one side, I can say x squared plus x minus 12 equals 0. Simple enough. Now this one, luckily, I can factor. I can say, well, that's just x plus 4, x minus 3 equals 0. And so then, by the zero product property, I can then pull out these into individual factors. I can say, well, then x plus 4 must be equal to 0, and x minus 3 must be equal to 0. So that tells me that when x is 3, they have the same output, and when x is negative 4, they have the same output. So that means negative 4 and positive 3 are going to be my bounds. Simple enough. So to reiterate, what we're going to do is when we see these things cross over, we're going to say, well, in those cases, the function outputs have to be equal to each other. So we set the functions equal to one another, and we find the input values for which the function output values are the same. Those are going to be our bounds. So from there, we can start to set up our integral. We can say, well, my area is from my leftmost bound, negative 4, to my rightmost bound, positive 3. But remember, we have to say, okay, well, one of these functions bounds the other. One of them's on top and one of them's on bottom. So then I can say, all right, well, the one on top looks like this straight line. Well, it's supposed to be a straight line, not the way I drew it. But when you draw that, it is 12 minus x. So I say 12 minus x is on top. And then on bottom is this x squared. So minus x squared dx. Okay, so that's my setup. Now from there, what I want to do is I want to solve this like a definite integral. Let's simplify this so that it's kind of ugly. Let's make this a little less ugly. So then we would say, all right, that is the definite integral from negative 4 to 3 of 12 minus x squared dx. Okay? At this point, what we need to do is apply our techniques of integration. We need to antiderive these things. So the antiderivative of 12 is 12x. The antiderivative of x is 1/2 x squared. And the antiderivative of x squared is 1/3 x cubed. All from negative 4 to 3. Okay, so now we need to keep on going. From there, we need to plug in the case where x equals 3. So that is going to be 12 times 3 minus 1/2 3 squared minus 1/3 3 cubed minus, now we're going to do the case where x is equal to negative 4. So 12 times negative 4 minus 1/2 negative 4 squared minus 1/3 negative 4 cubed. Kind of running out of room there. Let's keep on plugging in here. We're going to get, that's going to be 36 minus 9/2 minus 9. Hopefully that was simple enough. You're comfortable enough at this point to do that. And over here, we're going to be subtracting negative 48. So that's going to be minus 8 So 4 cubed is 64, I believe. So we're going to get plus 64 over 3. That's because negative 4 cubed is negative 64 times negative 1/3 is a positive 64 thirds. All right, now we're going to go one more step. We're going to say 36 minus 9 halves minus 9. Now we need to distribute the negative, so we distribute it to each term, so that's plus 48 plus 8 minus 64 over 3. So if we combine all of that together, what we're going to get is, that's going to be 27, that's going to be 75, 83, so we get 83 minus 9 halves minus 64 thirds, which, give me just one moment, I'll check my cheat sheet. Alright, that seems to check out there. We need to get a common denominator. It's going to be over 6. So that's going to be, 6 times this would be 480 plus 18, 498. So 498 over 6 minus, this with the common denominator 6 is going to be 27 over 6. And this with the common denominator 6 is 128 over 6. So those will become 370. 370 minus 24 is 343 over 6. Wait. 340, yeah, still right. I'm sorry, I'm second guessing myself here. 343 over 6. All that to get 343 over 6. So that's a lot of work there. Mostly, notice that most of that work was actually on the integration side. We did a little bit here. The setup was pretty simple, and it was the actual integration that was the problem. It took up most of our time. So the key to these is actually to be pretty good at the standard calculus. If you struggle with the techniques of calculus in general, if you struggle here, like setting this up wasn't a problem, but if you struggle from here down, you're going to have a lot of chances to be wrong. So you're going to need skills on both sides to be successful here.